So as I was hopefully saying, I'm not entirely sure what was heard and what wasn't. Next up, we have Aaron Berkowitz, Senior Director of Technology at PBS Kids, to talk about unraveling the complex content models with GraphQL. And I'm super psyched for this one because I have a 7-year-old whose main TV intake is PBS Kids. So welcome to the stage, Aaron.
Thanks a lot, Brian. I appreciate it. I have 2 of my own who are, of course, viewers of PBS Kids. So it's great to hear.
Perfect. All right, we'll take it away.
Thank you. So like Brian said, I'm Aaron. I'm the Senior Director of Technology at PBS Kids. I oversee an engineering team full of front-end and back-end web developers, operations folks, services engineers, engineering managers, all sorts of great developers who help build and maintain the PBS Kids ecosystem and all the products that kids and families and parents get to use. For those outside the United States, PBS is the public broadcasting service in the US. It's comprised of independently operated television stations across the country that work to inform and entertain those living in the US. And if you're curious, if you're in the US, what your local PBS station is, stick around to the end of the talk and I'll share a link where you could run your very own GraphQL query that will let you find out. But I work specifically for PBS Kids, a part of PBS that serves children, families, caretakers, and educators with fun and thoughtful media. And our sort of tagline is, through the power of media, our engaging characters help kids learn lessons that last a lifetime. And we believe every child matters and is deserving of opportunity. If you grew up in the US or if you're a parent in the US, you probably recognize some of these TV shows that are available on our various platforms, including broadcast television and our digital streaming products. And everything we do at PBS Kids starts with and is measured by learning outcomes. For example, a show serves one or many specific learning goals. And here we have our very first content model connection. Learning goals are connected to different ages to help us identify growth milestones and what kind of content is appropriate for what ages. Shows, of course, have videos that have their own specific learning goals. But being a show on PBS Kids, it isn't just about video. We have apps and coloring pages and crafts and recipes and songs, all connected to their shows, their characters, and learning goals. We have specific experiences like the PBS Kids Games app that highlights specific games and shows, and the PBS Kids Video app that highlights specific shows and videos. We also have resources for parents. We have stations that connect and theme certain aspects of those different applications based on where you might be in the US. For parents, we have things like articles and birthday parties with their own learning goals and shows. And they also come with their own videos and coloring pages and crafts and recipes and songs, etc., that help parents contextualize the content their kids are enjoying. There's a separate parents learning goals framework that's all interconnected here that helps our parent audience find and understand what their kids are viewing and learning. So as you can see, our content is much broader than just videos. But this model allows us to do allows for some really interesting opportunities. For example, like me, you might have a 3-year-old kid who loves Daniel Tiger's Neighborhood. And as a parent, we're looking for games and videos to help with certain lessons like sharing or potty training or becoming a big brother or sister. And the possibilities within this model are endless. And I'm sure many of you out there as graph developers can see that this model, after all, is just a big graph of connected content types. Now, this is a subset of our much larger content model. The full model looks something more like this: hundreds of content types, categories, assets, fields, and more, all deeply interconnected to form the full catalog of offerings at PBS Kids. So this is a big challenge for us from both a technical and content and product perspective. How we make sense of this big map and how do we create experiences that help kids and parents find what they're looking for. One piece of this technical puzzle is where the data lives. This is a version of a slide that I often use when talking to different stakeholders and leaders at PBS to illustrate the value of things like GraphQL. So of these 5 products or experiences across the top, there are 8 or so different places where data might come from, maybe each with their own API style or caching strategies, authentication needs, release cadences. And if we assume that each of those products is built by different teams of developers, that's a lot of knowledge to keep track of and experiences to keep up to date. If one of these things has a version change or one of the APIs has a version change, there's a lot of work that goes into maintaining all these different applications across all these sources. So a few years ago, as the PBS Kids for Parents website was undergoing a full redesign and reimagining, we sought out tools to help us navigate the complex data model and quickly get data from these sources to our users. And of course, GraphQL came to the rescue for us. The craziness of this API and connection layer went to this. And app developers only needed to learn how to query the graph for content and not worry about all the intricate details of each data source. If any data source needed to update, we only needed to change how new responses are handled at the graph layer, allowing for our app to have a much longer adoption timeline. There isn't so much urgency in updating our mobile applications or our websites, and allows for a much longer tail of deprecation for different fields or services. GraphQL also unlocked this model in really significant ways. Instead of dealing with dozens and sometimes hundreds of API calls or super complicated backends, we can use GraphQL to help us navigate from node to node and pull content that our users are looking for. So we can dive into a real life example here. This is a screenshot from the PBS Kids Games app, which is available on iOS and Android devices in the US. And just looking at this home screen, we can see a few different kinds of data. We have shows on the right side with their circle icons highlighting their characters. At the top, we have a featured game, which is a game of the day and a theme behind it. This is one of our fall themes where you can actually wipe the leaves away or rake the leaves away off the top of the game. And then at the bottom, we have the top row of our big game grid. If you were to click into one of these shows, you would see you're contextualized into the show itself. This is Rosie's Rules, one of our newest shows. And you can see the games associated with that show and also English and Spanish language tabs that show you the different versions of the show in each language. If you're a grown-up and interested in more detail, you can click on that Grown-ups tab, and that pulls up more information about each show. This is for Eleanor Wonders Why. See things like age ranges, learning goals, sponsors, and things like that. So if we were to use, use a more traditional API approach, not GraphQL, say we have a simple data API that returns specific content items and only identifies their relationships to other things using things like IDs. So you might have a show that has images, and in the API, you only get the ID of that image that it might be associated to. So you can see here for our 250-ish games, to load in all of that data, we're pushing 900 API calls. That's a ton of API calls to get all this information together. So instead, of course, through the magic of GraphQL, this is an example of a query that we might use. We are able to write queries that fetch the data we need with far less complexity. That allows us to pull all of these different content types and their connections through GraphQL in a much easier way. So why is this important to us? Going from around 900 API calls to about 25 API calls. And this is important for a number of reasons. It makes our client applications much easier to build, but also makes them far more accessible for families without broadband internet access or unreliable connectivity. And that's a huge part of our mission. Research that I often refer back to from the Pew Research Center, there's a link on the slide here, that 15% of Americans, this is from last year, are smartphone dependent, and 30% often have trouble connecting to the internet at home. So what does that have to do with GraphQL? Well, it has to do with the way we're able to optimize our experience for those who don't have stable and reliable internet. Additionally, the research shows that the less money a family might make, the more dependent you are on smartphones and data plans. And also the less less educational opportunities you might have or family might have, the more likely they are, again, to be smartphone dependent. So tools like GraphQL are incredibly helpful to reduce the strain on families with wobbly internet connections or cell phone data plans that we don't want to use up everybody's data all of the time. A quick plug on that note. We are working now on a really major project. This is from today, the homepage of pbskids.org. We are working on a full redesign and re-architecture of pbskids.org to make use of technologies like GraphQL, progressive web applications, concepts like progressive enhancement to help reach kids wherever they are on whatever devices they have. So maybe next year or the year after, someone from our web development team and our services team can come back and explain just how they accomplished it. It's really going to be amazing. So back to the graph here. Some features, key features for scale for us. And by here scale, I don't mean the amount of traffic we get in our system, but more how we're scaling it internally as a product and a service that we're maintaining. So two important things here, useful interface and what we call magic resolvers. So our data model, back to our data model, this is a more programmatic or software kind of approach to it. Everything, we refer to everything as an element. That's a term we borrow from Craft CMS, which is the CMS we use that powers most of our applications, as well as the biggest data source for a graph. So everything is an element, and then we have these sort of subtypes that implement an element interface using, so we have CMS entries, categories, and global sets. And so what happens is the element carries with it things like an ID, maybe an author, a post date, expiration date, sort of the basic parts that we would need no matter what. And then we have entries, categories, and global sets, each with sort of various fields and categories that will work for those types. So games and videos extend the CMS or implement the CMS entry interface, learning goals, implement category, show promotion, seasonal themes like that, all implement things like global sets. One important part that we have here is a field called related to, which really powers that real interconnectivity. So all of these things, it starts with an element, has the power to say, all right, based on this element, find me all of the learning goals that are connected to this one. And based on the learning goals, find all the games that are connected to those learning goals, or from those games, find all the shows. So we start seeing this real graph traversal capability based on this related to field, which on the back end just runs a search against our CMS and returns stuff, and really allows us to dive very deep into this content model. The second part we have here is what we call magic resolvers, which was a way for us to be a little bit lazy in our development, but really helpful in keeping consistency across all these different types. So we use Apollo for our GraphQL server, and we run it on AWS Lambda. So a server startup for us is almost every, or cold start invocations, if you're familiar with Lambda. And when the server starts up, we make use of GraphQL's native introspection capabilities. We examine all of our type definitions. We go through each one and look at any fields in the entire schema that might return an element or an array of elements. And based on that, we dynamically add this generic resolver that will go fetch that element from the CMS, and then we build out the schema and the queries and resolvers and really start the server and allow requests to start coming in. So this allows us to really quickly expand the way we are expand the different types of content that we have in the graph system. It creates a lot of predictability that allows us to bring on app developers quickly and have them understand this very common pattern based on this inheritance that we have here. And that's been really helpful in adding all these types. So a little bit about some at-a-glance stats. In the last 30 days, we had 1.6 billion requests in the last 30 days. About 20 or so different client applications across different environments. We have, of course, production and some staging and QA environments. A little over 200 types, a little over 2,000 different fields, and about 173 queries that we have. So as promised at the beginning, I'll leave this up for a minute for you to grab a screenshot or write it down. If you're interested in what your local PBS station is, here's where you can check it out. A big thank you to Dylan, Yusuf, and Nathan on my team at PBS Kids, who really helped spin this small demo up yesterday when we came up with this idea. And this will bring you to Apollo Studio, which is, again, our graph server that we use. This will only work in the US. We don't localize outside the US, but you'll be able to really kind of explore some of the data offerings that we have for stations, what your call sign might be, the name, city and state, and of course, donation URL. Please give back to your local PBS stations. It's how we run a lot of the great content. That's all I have. Thank you so much for having me. And for more of our content, please visit pbskids.org or pbskidsforparents.org. And Brian, I see you're back. Happy to answer any questions that might have come in.
Yeah, totally. So again, thank you so much for coming and giving this presentation. Some round of emoji applause in the chat would be great over in the stage. Also, any questions you've got? I see we already have one from Alex in the chat. The question is, where did the push to move to GraphQL come from? Was it business, engineering, product, or some combination?
Great question. It was engineering. When we were looking at the early designs of the parents website, which if you go, it's pbs.org/parents. It's very search-based. It really makes use of that very complex content model. And you can imagine a parent trying to find content that's relevant to their kids, maybe relevant to what their teacher's recommending a kid focuses on, or you're looking for activities that you can print out at home. You can see how a parent would think through, okay, well, I have a 3-year-old, or I have a 6-year-old, and they're really into the wildcrafts, and they really love animals. And I would love some games or some activities related to that. But the holidays coming up, you might be looking for PBS Kids themed Thanksgiving decorations or activities you can do with your family. So we were thinking through the different ways parents would approach navigating this site. And with the CMS that we had, we knew we could do this through the CMS, through like a more traditional API. We were worried about speed and the sort of maintainability of really complicated database queries against these thousands and thousands of pieces of content and how they're all interconnected. And so my team is very familiar with all those circles and lines. I use diagrams like that a lot. And it sort of dawned on us one day that, like, hey, this is a graph. Like, how can we find ways to navigate this graph and jump from node to node and expand on each one and limit the responses from each one? And GraphQL became a very clear answer. So we built it from engineering as a sort of a response to, I guess, some product requirements. I'm very fortunate at PBS Kids. It's an incredibly collaborative organization. So we work very closely with our product and design teams. So we're able to come up with those solutions together and really figure out ways to make the products work.
Awesome. And out of curiosity, I saw kind of the nodes and edges and all that, the circles as you referenced them earlier. Have there been any insights that have come out of making these connections? Because one of the things I really love about content in the graph is that connections you may not have been aware of surface more easily when you look at them as a graph. And any new insights come out of that?
Absolutely. One thing we're able to do now is what we call sort of a gap analysis. We have this very extensive learning framework that has thousands of nodes to it. This big hierarchical structure. It's very academic. It's not meant for our end users. If you're interested, the parents learning framework side of it maps back to the kids one, so it allows us to get content out there. But what we're able to do is look at that big framework and using Graph, search out content that we either have or more importantly don't have. So we might find, hey, we're really lacking in this particular math skill or in this reading skill or in the social emotional growth skill. And we'll use that to think about what's next for us as an organization. What funders we might need to reach out to who might be interested in some of those topics that will allow us to fund new content opportunities. Or we might say, like, the example of crafts for the holidays, go out and find folks who are crafty and will make things for us for the parent side or make things for the kid side. So internally, we use it a lot for these sort of audit reports and finding things like that. That's been really helpful. It also sort of demonstrates the really important parts of that model, of course, are the shows and their characters and these learning frameworks. When you have the full model out there, everything connects back to those 2 points. So when we're thinking of designing new products and how we're going to engineer them, we know that the shows are at the heart of what we do. So making sure that those are always sort of front and center for the kids to navigate. There's always good show navigation for kids and parents, and that sort of is highlighted by just the nature of the model itself.
Amazing. And so one other, there wasn't a question, but a comment, just that the magic resolvers sound awesome, and some applause around that specifically.
Yeah, great. Yeah, we've toyed with that when we first started using Graph. We in my mind, it was sort of this like golden ticket thing, like this is going to be a great problem solver. Of course, it has its road bumps, and we've hit a lot of them in terms of scale and sort of the maintainability. We did search really wrong in the first iteration of our graph, so we had to sort of go through and do it all over again and update all the clients, which was not the very graphy way to do it, but we sort of had to figure out how to make that work. And the magic resolvers are sort of a key part of that to help us quickly add new things and not. We felt like we were repeating the same lines of code over and over and over again. Okay, if you need this asset, you need this resolver. And so we figured out through inheritance, we can just find the things and just add them to the schema for us. And that's turned out to be really nice.
Awesome. All right. Well, another round of applause. And thank you so much, Aaron, for sharing these insights and for talking things through with us. And I hope you have a great day.
Thanks a lot.